So yesterday our learning goal was I can graph functions given a specific domain. In other words, in set notation, they gave you some numbers and said these are the values we want you to use for x. And that's how we knew it was a specific or a specified domain, is they were written in set notation behind the function. It said domain, and then it gave what it was. Today, our learning goal is, let's look up here at the board. I can graph functions with a domain of all real numbers. Anybody know what that means when we say that all real numbers are in the domain?
There's no negative.
There's no negatives, so negative numbers are not real? What do you think? Are negative numbers real? Yeah, they actually are. Are fractions real?
Yeah.
They're actually real too. So when I say all real numbers, here's what you should visualize. The whole number line. Everything that lives on the number line. Fractions, decimals, pi, whole numbers, negative numbers, the works. Every number that lives in the number line is included in the all real numbers. Now we can't even begin to list them all. So that means we are going to be doing continuous graphs today instead of discrete graphs, because we're going to have to pick our own x values. We're going to have to pick some numbers from that number line, and we're going to have to plug them in, plot them, and then we're going to draw a continuous graph with it, okay? So we're going to choose values for x, both negative and positive. We're not going to just stick with positive because we like those better. We're going to write ordered pairs again. After we get our y value, we're going to write those ordered pairs that we can then go and graph. And after we graph them, we will make it into a continuous graph by saying, do they line up in a nice line, or do I need to draw a smooth curve through them? Are they like maybe a U-shaped graph or something else, okay? So, here's our first one. Y plus 2 equals 3x. First decision we need to make is it solved for y? Does it have y alone so that we know what the function rule is? No, it isn't, is it? So what should we do to this first? Subtract 2. So our first move is going to be to get this so we know what the function rule is. Right now that y is not by itself. So we now have y by itself, and the function rule says take 3 times the x value and subtract 2, and you will get the y value. So we're going to move our function rule down here to our table. And we're not going to draw our other column yet because we don't know how much space it's going to take us to show our work. So the first column are the x values that we're going to pick and put in there. The next column is our function rule. What do we have to do to those x values? Our next column will be, well, what's the result? What did we get for y? And then last but not least, what's our ordered pairs? What are the ordered pairs we're going to put on the graph? Okay, we need to pick some negatives and some positives. And I'm going to say that we have to pick 5 of them, 5 points. So let's start with negative 2, okay? So it's kind of like I'm just picking for you. And how about we just go negative 2 through positive 2? We're not going to include any fractions, any decimals. We know that they would be part of the graph, but we want to make it so that we can just get some nice values for this and be able to graph points and draw a continuous graph. So we're going to substitute just like we did yesterday. This is our substitution step. Now, many of you went straight to substituting and then magically you got the y, because either you were doing mental math or you were letting your calculator do it. Every time you write it down, every single time you write something down, you implant it in that brain better. You will retain it longer. So you're going to not just go right to what the y value is here. You're going to say, what is 3 times negative 2? Because order of operations says do that first. Negative 6. And then we have to subtract 2 from that.
Negative 8.
And then we can say, oh, I guess I'm going to be at my y's now. Now we're going to say y is negative 8. So we substituted, following order of operations, we multiplied first, then we subtracted, we got our y value. Now we're ready to write our ordered pair, x, y. So our ordered pair for this one is what? What's our ordered pair? Negative 2, negative 8. Okay, you go ahead and complete that table now, because you know how. We did this yesterday. The only thing different is we had to pick our own x values. And if you're uncertain of yourself, you want to, after each one, check to see if you agree with me. You can. If you need to challenge me, you can. After you've had your 5 ordered pairs, if you want to verify with the table I have up on the smartboard, you can, and then you're ready to go graph your points. And I'm going to put rulers on your table because every time we graph, we're going to check to see if we have something that we could draw a line through. If they line up in a line, we're going to do a line instead of a straight curve. And it does appear they are linear, so we should be able to line up our ruler going through them and draw a line all the way through the graph with arrows at both ends showing that it is, we didn't even begin to cover all the x values. We don't want to make a table for the rest of our lives, so we actually could. Mine didn't go through very well. Let's try again. Okay, so again, after you have your 5 ordered pairs, verify that you have good ones by looking up and checking out mine. And if you think I need to be challenged, you may challenge me. Plot your 5 points. Use your ruler to draw a line through them because they appear to be linear, and if you line up your ruler through them, you see that they are. You do not just connect those 5 points. This is an all real numbers domain. Every x value on the number line has a y value in this function. We just found 5 of them to help us get a graph. So continuous graphs today, when it is all real numbers, when we choose our own x values.
So do we write continuous?
You know what, let's do that in our notes. Let's put that we have a continuous graph. It's a good idea, Adam. Because if I asked you how many points this function had, we would have to say it actually has an infinite number because it's continuous. We just only found 5 of them to help us graph it. Okay, questions at all on this one before we try another one? Okay, so how many points am I going to have to find? 5. Okay. Okay, let's go to the back then and let's check out what our next function is. We have f of x equals the absolute value of x minus 1. Okay? So, what did we do yesterday when we had f of x there? Just to make it kind of like...
Made it a y.
We made it into a y. We just renamed it and said, you know what, that's really the same as y equals the absolute value of x minus 1. Do we know our function rule already? We do, don't we? The y's alone. So our function rule for our table will be the absolute value of x minus 1. Be really careful with those absolute value bars. They get really confusing because ones look like vertical bars, just like these absolute value bars are vertical bars. So make that one shorter than you make the absolute value bars.
Now you can just do like
Don't be skimpy with your absolute value bars.
now you can just do like a line and
Maybe a different kind of a one. You could do that too. Give it some tails and bases and all that kind of stuff. Okay. Now, we're not going to make our next column because we don't know what it's going to be, right? So, today what I'm going to suggest is you probably should be able to always get away with choosing between -2 and +2, okay? And I'm just going to look at your homework really quick and see here. Yeah, I think we should be able to do that. So, let's go and put -2 in again. -1, 0, 1, 2. Let those be our x values. Now, some of us are not showing near enough work in our table for these absolute value ones. So you must show what I'm going to do right here, okay? So pay attention. We're going to put a -2 in for our x. The absolute value bars, everything, every part of the function rule is still there. The only thing that got replaced was the x. So I have -2 in place of x, subtract 1, absolute value bars around them. Now, absolute value bars are kind of like parentheses. Kind of like do what's inside of them, and then we'll get rid of the parentheses later. We're going to do what's inside of these absolute value bars, and then we're going to get rid of them later. So they're staying there. And what is -2 subtract 1?
-3.
-3. So that becomes the absolute value of -3.
And then we put another equal sign.
And now we're going to put another equal sign. Can we take the absolute value of -3? Would that be our next step? Which would be our y value, right? So you know what? Looks like we're ready to say, here's our y column. The absolute value of -3 is 3. So, ordered pair x, y. Yesterday though, how man should have a pencil every day?
Yeah, I did, but my bro. Okay.
What's our ordered pair? What's our ordered pair?
-2, 3.
-2, 3. Okay. Every one of these requires that much work shown. So go ahead and finish your table. Go ahead and finish your table. Hopefully, as you're doing these, you're seeing patterns that should be happening. Each problem has its own kind of pattern, typically. What I'm seeing in this one is my y values are going down by 1. Does that mean that pattern will keep going? Not necessarily. So don't get tricked into thinking patterns always keep going.
So for the regular number one, we just put 0 and don't put that negative sign. For like
For when x is equal to +1. So right here, are you talking about this row?
Yeah.
Right there, Adam? So we put
So we
1
just
in
put
for,
0.
yes, because we don't need one take away 1 is 0. And you're right, 0 does not have a sign. Okay, after you have those 5 ordered pairs, you can check it out to see if you agree with me, and then if you do, you're ready to go and graph them. This is a continuous graph. And remember what I said yesterday? When we have absolute value bars, our points should line up in a, what kind of a pattern? What did I say? What kind of a pattern will absolute value equations make, functions make? A straight line? A V, yeah, a V. So this one's kind of a partial V though, isn't it? Looks like a backwards check mark, doesn't it? That looks like how my husband would make a check mark because he's left-handed. So what we're going to do is we're going to take our ruler and we're not going to go past this point down here because this is what happens in an absolute value function is it stops at a certain point and it either bounces back up or it bounces back down. This one is bouncing back up. So what we do is we take our line and we draw it like this. Do not go past that bottom point there. And then we take our ruler and we draw it going the other direction like that. So we still have our V, it's just that our points didn't quite exactly, match up. You're right. We didn't have all the symmetry that's really going on there. So we have a V-shaped graph that we don't want to make into an X by extending those lines past that bottom point. Okay? So what I might do when we start the homework is I might help you pick some X values that I think are going to be good ones for you because I don't want it not to go well for you. You'll get eventually good enough, you'll be able to pick your own. But anybody have any questions on this one? So absolute value, so when we have the absolute value, we should expect a V-shaped graph, shouldn't we? Okay, number 3. This one doesn't have any absolute value bars. It doesn't have just a plain X, it has an X squared. So this is going to be a different type of graph. Yeah, we're not going to use our rulers for this one. So Holly, is this one ready for us to say what the function rule is? Okay, Maisie? Yeah, it is, isn't it? What is the function rule?
-2x squared minus 1.
Yeah, negative 2x squared minus 1. So, again, we get to pick our own X values, but be careful, we're going to need more work room in this one, so that because the graph is kind of off to the side, we can't let our table go on forever. So here's what we're going to do. We're going to do negative 2 again. We're going to skip a line so that we have some extra room for work. Negative 1, skip a line, 0, skip a line 1, skip a line 2, okay? So we need extra room this time. So we're going to substitute in, we have our negative 2, our X value is negative 2, we have a squared sign outside that second negative 2 in parentheses, and then we have subtract 1. That's all we're going to do in that line. Now we're going to start working below it and see what we have to do. Hear me on this. Hear me on this. You have to put parentheses around negative numbers when you're going to square them. And so I'm using parentheses because it's a negative number, and I'm kind of using it as multiplication. Because that negative 2 in front of x squared says you have to take negative 2 times x squared. But you have to be really careful here. Here's what students tend to want to do. They tend to want to take the negative 2 times the number that got substituted in. They want to do that first, and then they want to square it. We have to do the squaring first. We have to do the squaring first. So we're going to take this part right here. This is going to be the first step we're going to do. We're going to leave that negative 2, and we are going to replace negative 2 squared with whatever that is. What is negative 2 times itself?
Negative 4.
Negative times a negative is a? Positive 2 times 2 is 4. This should just be positive 4 here. And then we have subtract 1. We're not done. Equals. What would we do next? Yes, sir. Why do we always go sideways? Oh, you mean up here? Because I kind of wanted it to be clear to you what we did here. Okay, if it's right below it, then it makes it clear. Plus, if you write like I do, Seth, I would have run into this graph. I would have run out of room. Okay? If you can fit it all there and you're going to be able to make sense of it and you're not skipping any parts because you run out of room, you can. Okay? Okay, anybody else got a concern? Okay, so what do we do next?
Multiply that negative 2 times 4.
Yeah, take the negative 2 times 4. What's that? Negative 8. Subtract 1.
3.
Because remember, we're going to make a y column and an xy column yet, you guys. So now we have, are we ready to be able to make our y column? Yeah. Okay. So we're going to have our y's next. What does y equal then for this one? It's 8 below 0, it drops another degree, it is negative 9. It's 9 below 0 now. And now we're ready to write our ordered pair column. And we have ordered pair what? Negative 2, negative 9. Okay. So go ahead and find your other 4 points for this one, following that process. Pardon?
The first part's the same on all of it,
I mean, the substituting. And
isn't it?
this?
You square the same one every time.
No, you're squaring the x value that you. But this it's always negative 2. But what changes is the x. Yeah. Okay. Just not sure, I guess, that I understood what you were saying. Okay, so I have all 5 of my ordered pairs, so that when you get yours done, you can check to see if we agree. And I'm going to guarantee you that I'm right. So maybe if you don't have that, find where yours went wrong. Now, after you get your 5 points down, we're going to talk. So I just graphed mine in the same colors that I did my work in. So while you're waiting, take your ruler and see if you could make a V out of this, upside down V. In other words, don't draw. Just see if you can line up the ruler, making a V with could your ruler really line up like this was linear? Could this side really line up like it was linear? In other words, are these also V-shaped tracks, you think? Try it with your ruler. Don't draw. Don't draw. Just line them up and see if you can actually make the ruler line up through those 3 points along the side without having to fudge. Can you, Maisie? Can you, Seth? We should not be able to. This should not give us a V-shaped graph if it's not an absolute value one. This one is what we call a U-shaped graph. It has a special name called a parabola, which we'll study next year. But it's a U-shaped graph, so we're not going to use our rulers this time. What we're going to do, and usually the easiest way to do this, for me anyway, instead of starting at one and trying to work my way all the way around, what usually works better for me is to kind of start with a curve going like that one. Yeah, I start like that. So I round, because it's a rounded, there's no sharp corners or no stopping. Your pencil just makes a nice smooth curve, and then I just go and finish the other part also. So it looks like kind of a skinny-based U, upside down. It's not a V, we can't use our rulers for these. Okay? So, if they have X squares in them, you should get U-shaped graphs. They should either open up as a nice U, or they should open down. If you have an absolute value, it should be a V-shaped graph that you can use your ruler for, that opens up or down. If it has just an X in it, no absolute value bars, just an X not being squared, you should be able to line up a ruler through and draw a line. Okay? Those are the three types of graphs that you should be experiencing in your homework. Okay, questions on this one or going back to any of them? Anybody not done, need it left up here longer? You have the visual that you need? Okay, let's go to sheet of loose leaf paper and okay, so on your loose leaf paper, write down what you're going to do. I'm going to get you a graphs handout. And I'm going to, for some reason I couldn't stop my recording properly here.